Now we can use that for that stuff up there. So, that means then that we're on the numerator, we're going to have the concentration of propionic acid, HC3H5O2. And if you wanted to use HP for that, by all means use it. It's a lot easier than writing all that slop down. But you've got to be careful of that because you've got to remember that you have an OH you got to deal with. It is not involved in that. But if you understand that, that's fine. There'll be OH negative on top. And then on the bottom is going to be your base, your C3H5O2 negative. And that's going to equal your Kb, which is 7.69 times 10 to the negative 10. Okay? So, we are told that we have 0.025 molar of this stuff right here. But we're going to lose X. And let's do that up here first before we get too ahead of ourselves. We have 0.025 molar of this, like we said right there. It's going to lose X here. It's going to gain X here. It's going to gain X here. That's our mini ice for that. So like tiny little ice cube. I love it. They're so cute at that age. So we plug that in there. And that's going to be X times X here. Your 0.025 minus X on the bottom. So that's going to give you X squared over 0.025 minus X equals 7.69 times 10 to the negative 10. And in algebra, when we have a fractional variable equation, we get rid of the denominator. So we're going to multiply both sides by 0.025 minus X. And that gives us X squared equals, and I'm going to rearrange this so that the X is first and the non-X is last. So that's going to be a negative 7.69 times 10 to the negative 10x plus, because that's positive. And when I multiply this garbage out, I got 1.92 times 10 to the negative 11th. But I need this in quadratic form, so I'm going to move this over here by adding negative x squared and sticking that in front because that's a higher degree than x. So that becomes 0 equals negative x squared minus 7.69 times 10 to the negative 10x plus 1.92 times 10 to the negative 11th. Now I have quad form. A is negative 1. B is negative 7.69, E negative 10, and C is 1.92, E negative 11. Notice I put that there because we're not using, we're not coming up with an answer just yet, so I would have E there, so you punch that in your calculator without wasting all that energy on the times and carrots and times and all that tens and stuff. So anyway, punch that in your calculator. You get two answers. You want the positive one, which I got to be 4.38 times 10 to the negative 6. And because X is your hydroxide concentration there, this is OH negative. So your POH is the negative log of that, which turns out to be 5.36. And your pH then, remember, POH and pH add up to 14. 14 minus 5.36 is 8.64. And there's your answer for that. Now, X is also the concentration of propionic acid. So there's your second answer. We'll put that down there. Equals HP. I'll just put PR for propionic. I don't care. or write the whole thing out. We don't really care. But that means that is the other answer you're looking for. These are your two answers. All right? Last problem. Now we got an acid. So that means we should end up with a pH of less than 7. Let's find out. Stay in your seats. Now, what we're going to do at this point here is that we're going to recognize the base that this came from. Okay? So, the difference between acid and base is going to be a hydrogen. Now, if I were to dissolve this in water, the Br is going to be completely coming off of it. So that becomes Br negative plus C5, H5, and H positive aqueous. Okay? Now, that is the conjugate acid of one of the bases on page 736. So if I remove that acid, the conjugate base becomes C5H5N. Well, we had that once before. I believe that was called pyridine, wasn't it? It is pyridine. Okay. Pretty sure it is. Yeah. Okay. So, the Kb for pyridine we found to be 1.4 times 10 to the negative 9 on page 727. So the Ka is, which is what we need for this reaction that we're going to have when we dissolve it, the Ka for this is 1 times 10 to the negative 14 divided by 1.4 times 10 to the negative 9. And that gives us 7.14 times 10 to the negative 5th. Okay? So, now, let's dissolve this in water. We got rid of the bromide. The bromide's like the sodium, it's a spectator ion. We don't want it around. So we got C5H5 NH positive aqueous. And since it's an acid, I'm not going to add water to it. We know that it's in there. It's hydrolyzing off the water, but this hydrogen is going to come off. H positive aqueous. And then everything else left over is the base, C5H5N. All right. So, stay in your seats. So, Ka is equal to concentration of hydrogen times the concentration of the aniline divided by the concentration of the amylinium. Oops. Gravity. H5N H. Okay? And we are given in this problem, let's see here. I think it's 0.15 molar. Yes, it is. So this is 0.15. We're doing a little mini ice thing with a little ice cube. X minus X there, X and X here. So this can become X squared over 0.15 minus X equals the Ka, which is 7.14 times 10 to the negative 5th. So we're going to do what we did with the other one, and that is that we're going to go ahead and make a quadratic out of it. But, and there's always that big but, the X now is hydrogen instead of hydroxide. So we don't have to do that POH thing, we just go right to the pH. Ooh, that's exciting. So, let's go ahead and multiply both sides by 0.15 minus X. And that's going to give us x squared is equal to, and I did a little calculation on this. We got, well, this is going to be a negative 7.14 times 10 to the negative fifth x, because I'm putting that in front. And then plus 1.07 times 10 to the negative fifth. Then I'm going to move the x squared over, put it in front, because I'm going to go in order of the exponent values. So that's negative x squared. Oh, that's going to equal to 0 because nothing's left over there. Subtract the x squared to negative x squared minus 7.14 times 10 to the negative fifth x plus 1.07 times 10 to the negative fifth. Get your quad form warmed up again, and this will be negative 1 for x squared, negative 7.14 e negative 5 for f, for b, negative 1 for a, and this for b, and c is 1.07 e negative 5. Get two answers. Pick the positive answer for this, which I got is 3.31 times 10 to the negative 3 moles per liter. And that is equal to your hydrogen ion concentration. So the pH is equal to the negative log of that thing right there. And we get 2.48. And there you have it. Just some little funs and games to play for this week using weak acids. All right, so practice problems. 52 to 60 even on page 753. Put on your big boy and girl pants, you've got some serious work to do. Have fun.